Hi, so today we're going to learn quick sort. So when we say quick sort, I want you to think of a word, pivot. Pivot is one of the items in the array that has a following condition after we sorted it. First, a pivot is in the correct position in the final sorted array. This means that the item in the left are lesser and the item in the right are greater to the pivot. So, we're going to give you an example of it.
Today we're going to learn what is Pixar algorithm. Here we have an array which is composed of 44, 22, 11, 00, 33, 77, 99, 55, 86, 88, and 66. We choose one element as our fiber. So we choose 44 as our fiber to create and put it in the middle to create two sub-arrays. The left array is the distance of our fiber which is composed of 30, 33, 22, 11, and 00. Our right array is greater than or 5 is composed of 79, 77, 99, 55, 58, and 66. So that we're going to start the left array. So pivot here is 33, I is also 33, and J is 22. Since 22 is less than our pivot, which is true, I will increment and remove J to another element. It's J for 11 is less than our pivot 33. Where I increment and move to another element is 11. Then now we move G to 0, 0. 0, 0 is this the level file that it is true also. I will increment and move to 0, 0. I and 33 where our pivot is change places. It's also 0, 0, 22, 11, and 33. As you observe, we are not done yet. So we need to choose another pivot. So we choose 22 as our pivot. I is 22 and G is 11. G is less than our pivot 22. I will increment. I and our pivot is change places. Here is the result 0, 0, 11, 22, and 33. As you observe, we are done selecting the left array. Now we'll proceed to the right array. So we choose 77 as our pivot, 19 as our G, and 27 as our I. Since 77 is greater than our 99, which is false, I will stop and G is moved to another element. So G is less than our pivot, which is true. I will increment and I and G will exchange places. So we'll move G to another element. P is greater than our G, which is false. I will stop and G will move to another element. G less than our pivot is true. I and G will exchange places. Or I and P will exchange places also. So we are not done yet sorting the right array. So we choose 66 as our I and 66 as our pivot and G and 55 as our G. Since G is less than our pivot is true, I will increment I and our pivot is exchange places. So this is the sorted array. 55, 56, 77, 88, and 99. The sorted array is 0, 0, 11, 22, 33, 44, 55, 66, 77, 88, and 99. That's all. Thank you.
Let's create a simple quicksort code. If you run this code, as you can see, the numbers is not sorted. First, let's create a quicksort function and there are three arguments. The array start is 0 and end will be the array that length minus 1, and don't forget to declare this function. Let's rename this parameter, so this will be the starting index and this will be the ending index. Let's create a base case. If end is less than or equal to start, return. Let's create a pivot function. Just copy this and make a few changes. I will make it in partition and put return I because this will be the location of the pivot. Let's make the location of the pivot in pivot equals partition array start and end because the partition will sort our array and find the pivot and separate the lower to the left and higher to the right. Let's create the left pivot. Quicksort array start and pivot minus 1. The right is the same but change the start to pivot plus 1 and end. Let's make the quicksort function. In pivot equals array index of end and I will name the two index I and x. Index I equals start minus 1. Now we will make a for loop. This is where we put the second index. Int x equals start and for loop will continue until x is less than or equal to the end of the array minus 1 and then increment x by 1. If our index of x is less than the pivot, increment I by 1. And now I will do a basic variable swap and temporary variable or temp equals array index of I, array index of I equals array index of x, and array index of x equals temp. When the elements is less than the pivot, it will go on the left hand side, and the larger the pivot, it will go to the right hand side. Now, we will put increment of I by 1. Now, we will make the final step for the pivot. We will just copy the basic variable swap and change that array index of x to end and array index of x to end equals temp. And make sure the return of I is in the end. And when we run this program, the numbers is now sorted, and that's how to make a quicksort program. Thanks for watching.